This is an introduction to our Texas Instruments calculators that we'll be using in this course. By the end of this video, you should be comfortable using it for the basic calculator functions, and then we're also going to do a little bit of graphing, just kind of following up with what we talked about in section 1.1. So the first thing you probably need to know, and hopefully you have your calculator in front of you. If you haven't yet acquired a calculator, know that that is a required thing for this course. And not only will you be using that as you work through things in the lecture, we're going to be pulling them out here and there, and for your homework, you will need to have it for your quizzes and tests. No other calculator will be allowed during testing, so make sure that you do have your hands on one. There are several different versions out there. It needs to be one that is Texas Instruments, 83, 84. It might have plus after the name or something else like that. They've kind of changed the colors and things along the way as they've updated the calculator, but the modifications are very, very small between the various models. So if there's ever a time that what I'm showing you just doesn't work on your calculator, it could be that there's a setting that's been set at some point, especially if you're using a used calculator. It might not have the default settings, or it could be that your model just has slightly different inputs. So don't be afraid to ask questions about that. A good place to do that is in our discussion forum, because that kind of opens the question for other people who may have the same issues. But you can also reach me during the office hours. For those of you that are in the hybrid class, we can talk about it there. And then, of course, you can shoot me an email. But for the most part, I think you're going to find that what we see here, this on your screen is the TI-83. I have in front of me a physical TI-84 Plus. Your model should be very similar to this. As I do things, I'm going to be doing them on my physical one too. So if there's anything that's different between those two, I'll point those out as we go. I think for today's, I don't think there are going to be. When we get into some of the more detailed things down the road, there may be some times that the inputs are slightly different. Okay, let's get started. First thing you probably need to know is how to turn it on, and there is an on button in the bottom left-hand corner. There we go. And one thing you might notice about the on button, just above that is the word off. It's in the body of the calculator, not on the button itself. On the one on your screen, it's in yellow. Your physical one might be different. The one I have in front of me, it's blue. So up here in that same line at the very top is a second button that should be that same color. So on the screen you see a yellow one. And if I just press that and then press the on button again, it turns the calculator off. And you're going to see on this calculator lots of different words in yellow. And again, yours will have a different color possibly. All of those functions are accessible by using that second button. So if we wanted to take the square root of something, we would press the second button and then this button right here that has x squared, but that would register as a square root if we've done the second button first. And the second button only works for one thing. So if you're doing multiple things that are those second functions, you're going to press it before each one of those. Okay, let's turn back on. There is a second function button. Okay, there we go. I don't know why it wasn't registering there when I was clicking. There's a second function button just below the second one, and it's called the alpha function. And on the one on the screen, that's in kind of an aqua green. The one in front of me is a brighter green. But you're going to find matching letters. It's mostly letters. There's a few things that are not. There's a space. But those are basically your alphabet. And so if you need to, for example, insert an X, you're going to do alpha and then press that store button, which also has the X above it. Okay, clear button is over here to the right. Let's clear that. We don't need that X there right now. So just play around a little bit and do just a few simple functions. This is a very straightforward way of entering. You're going to enter your first number. So if we're taking 23 times 3, we would just type out the equation just like we would if we were writing it on paper, 23 times 3, and then hit enter. That's like your equals button. and that calculated 69. If you're doing order of operations, just know, or if you're doing multiple functions at the same time, just know that this calculator does follow the standard order of operations. So if we did something like 23 times 3 plus 45 times 7 minus 98. So there's a lot of things happening there. There's some multiplication, addition, subtraction. The calculator knows order of operations, so it's going to do the 23 times 3 first, and then the 45 times 7 before it does the addition and the subtraction. And so there we get a number. If, for example, you wanted to take 23 times 3 plus 45 and multiply that whole thing times 7 before you subtract the 98, you would need to use parentheses to show that. This is going to be a really big number. Okay, so that's going to give you a different result because it's going to know to do everything in here and going to follow operations as well. So it's going to do 23 times 3 first, and then add the 45, and then take that sum and multiply by 7 before subtracting. Okay, so the calculator is smart about order of operations, but you need to be aware of that and just make sure that if things aren't following the order of operations, you use parentheses. There's even brackets on the function. The second function above parentheses is brackets. So if you need to nest some parentheses together because you have a lot of things happening, you can take advantage of that. There are certain things that have the built-in parentheses. Actually, scratch that. Okay, we've already talked about the clear button. That kind of just clears out everything. If you're on just this calculator mode, that's just going to give you a blank screen just to kind of clean things up. There's also delete and insert. So if you are, maybe you've entered a whole big long string of things and then you realize you pressed the wrong button. Instead of clear, which would require you to enter the whole thing, you can use the delete button, and in order to make the delete button work, you actually have to use the arrows to get back on the number that you want to delete. So let's say that we meant to enter 32 instead of 23. So I'd go back to the 3, hit delete, delete the 2, and then I could enter 32. If you make a mistake way over at the very beginning, maybe this was supposed to be 135, again, you can press that delete button. Now, if you now press the 1, it's going to actually override the 3. Okay, so that replaced the 3 with the 1 that I just typed. If we wanted that to be 135, instead of replacing the 3, I would have wanted it to insert the 1 in front of the 3. And so you can use the insert button here, second delete, and that's going to let me put that 3 back so that I have 135 minus 65. So knowing how to use that delete and insert is going to save you some time if you're entering some really long stuff and then you realize that you've made a mistake. Okay, a few other buttons that we'll use probably quite a bit if you're doing, some math on here. The square button is right here. So you can square 23 by just pressing that before you hit the enter. If you wanted to cube, that means take it to the 3rd power, 4th power, 5th power, you would use this little caret over here. And so that will take 23 times itself 4 times. Square root is nested. It's in the function above the square root, and you do put, or above the square, and you do put that in first, and then you would type the number that you want to take the square root of. Notice that it opened a parenthesis automatically. That means if instead of taking, so let's go ahead and do the square root of 25 is 5. We know that. Let's say instead we wanted to take the square root of 95 minus 18. I'm just making up some problems here. It opened those parentheses. You can close the parentheses, and then you can do some other things to that number and keep going from there. So this will do that subtraction first, take the square root of everything in the parentheses after the subtraction's been done, and then subtract 98. Okay, let me look at my notes. I think that covers kind of some basics. You can play around, look for other things on here that you might need to do. And if you do run into anything that you have questions on, just throw those our way. So let's move on to graphing. And by the way, I am going to post some additional graphing calculator resources in the resource section for this class, so you can look there for some documentation just to help you if you have some questions about how to use it. Okay, so let's use the calculator to sketch the graph of 3x plus 2y equals 18. Now we've learned how to do this. In section 1 we learned how to plot some points or find the x-intercepts and graph it that way, but we want to use the calculator to do that. Now to get started, you're going to press this button up here at the top that says y equals. And one requirement of using the graphing calculator is in order to input an equation, it has to be solved for y. It has to be y equals. And right now that's not what we have. We have an equation that looks like this, right? We have to solve it for y. That means we need to isolate the y, get it by itself. So this is some good practice of some algebra that hopefully you're familiar with coming into this class. So we want to move the 3x to the other side of the equation, so we're going to subtract it from both sides, and that leaves us with 2y equals 18 minus 3x. And then we completely need the y by itself, so we need to divide both sides by y. And remember, when you divide an expression by a number, you divide each of those terms, the 18 and the negative 3x, by 2. So 18 divided by 2 is 9. And then, of course, the 3 divided by 2 doesn't come out even, so you can leave that as 3/2 x. Let me pull the calculator back up. So what we need to type here is 9 minus, and then I would put that fraction in parentheses so that it knows. And fractions you can always enter as division, so that's 3/2. And then I need my alpha, and this is right down here at the bottom. Okay, double check. 9 minus 3/2 x looks good. So we've entered our equation, and notice you can enter more than one equation at a time. So if you wanted to have more than one graph on here, you could do that, and it would just show them all plotted on the same point, or on the same axis, or same coordinated plane. So now that we've entered it and we've checked it, go ahead and click graph, which is in the top right side of the calculator. And there we see our line. If we had plotted points, or if we had found the intercepts and graphed those, we would have had the same line as an end result. This is all of the points. Remember, our definition of a graph is it's all the points that make one. Now this, let's try another one. So this next equation is not a linear equation. We haven't talked yet about how you can tell if something is linear or not, but this will not make a straight line. The reason I know is it has this x squared, and we're going to dive into that a lot deeper as we go through this class, but for now, just realize not every graph that you might be asked to make is going to make a straight line. This is one that is true. Now, the nice thing is this is already in the form y equals and then the rest of the equation. So let me pull a calculator back up, and let's go back over to y equals. I'm going to clear out what is there and type in our new equation. I'm using the alpha button to get my x's. For x squared, I used the x squared button, but you do have to type the x. The x squared button just adds a square onto whatever you put there. Okay, so I've got my equation in. That looks good. Checking it over, kind of hit it. And now a parabola, which is the shape that a quadratic equation. Quadratic equations are those that have x squared. You don't have to know that right now, but we will get there. By the end of the semester, you'll know parabolas quite well. It's like the shape of the arch, kind of. It's turned upside down, so you can see it's coming down as we go from the left to right. It's coming down, and then it goes below the bottom of the screen and comes back up. So we really don't have a full picture of this graph yet. So if you were asked to sketch the graph, you really don't have enough there to be able to really see what it does, how far down it goes and things. So we want to expand the screen, and so we're going to use the the window button. The window button, it's up here on the top row, second button, brings up the settings for how big the screen is, how much it's zoomed in or zoomed out. So right now, everything is set to 10 units from the origin. So X-min means the smallest value on the x-axis, which is our horizontal axis. So it goes all the way down on the left to -10. On the right side, which is the x-max, that's our positive numbers, it goes up to 10. Let's skip over scale for a second. Y-min and Y-max do the same thing. So right now it goes down to -10 and up to +10. That's the range that our window shows right now. We found that this graph was going below the bottom of the graph. We could just bump all of these up to try to like zoom out enough that we get the bottom part of that graph. We really only have to go farther at the bottom, which is the negative y's. So I'm going to start, and it's kind of a guessing thing. If you don't, as we learn more about parabolas, you're going to find out how to find out where the bottom of the parabola is. But for now, we're just going to kind of eyeball it and say, well, what if we doubled that and we went down -20 instead of -10? And let's just see what that looks like by hitting the graph button. You don't have to go back over to y equals, you just hit the graph. And as you can see, it's still not quite far enough. It still goes off the bottom of the graph. So let's go back to Windows and let's try -30 and see if that goes down far enough. Okay, so now over here you would be able to draw the axes and draw the parabola and answer the question. So that's just something that you might have to do on some of your problems, is change the window if it goes off of, if the points that you're interested in, which in this case we were interested in where does that parabola shift and start coming back up. We wanted to see that, so we had to expand the window out, and the place that you do that is in the window settings. Now the number that we skipped over, the X scale and the Y scale, that is how often you're going to have hash marks. So if you're really expanding back, and some of our word problems are going to be dealing with, you know, like throwing a ball up in the air or even bigger numbers than that. So it's not just, you know, 10, -10, maybe bumping that up to 20 or 30. It's going to be like numbers that are several hundred or thousand. So it takes a while for the calculator to draw all those little hash marks. Plus, it's just kind of, you can't see them anyway. So you might change that if you were going to look at something and expand the window to where you were looking at hundreds, or you know, your maximum was 100. Maybe you'd make the scale 10 so that it would have 10 hash marks as it went out to 100. If your scale for your min and your max is like you know, 3,000, you might have the hash marks at every 500 or every 250 or 200. So that just makes it so that you can actually see those hash marks and be able to see what's going on with your graph. Okay, well, that wraps up this little introduction of the TI 8384 graphing calculators. We are going to be using these a lot this semester, and every little bit we'll get them back out and learn some more stuff. But you've learned the basics of doing calculations and the basics of graphing a equation. Okay, now that we have done the basics for the graphing calculator, I do want to show you some alternatives. The Texas Instrument calculators have been around for a long time. In fact, the first year that I taught high school, which was, I'm kind of embarrassed to say, was in '91, these were brand new. I think the model number then might have been TI 81, if I remember right, but they were a little bit fatter, a little bit bigger, but they basically functioned the same. Seriously, I taught for 3 years, and then I worked in the business world for 15, and I came back to teaching, and the calculator worked just about the same, and it still does today, pretty much the way that it worked back then. So at that time, you know, it was very new technology. It was very exciting that we could take a calculator and graph something. When I was going through math classes in high school and college, we never had that, so we were always plotting points. And of course, when you get to something like a parabola like this, you're plotting a lot of points before you can see what that shape looks like. So it really was a real breakthrough and exciting, especially for those of us that were educating and teaching teaching people how to understand math concepts. But it has been around, so the input sometimes feels a little bit dated, but they really are good for classroom, and that is what you need to do the tests in this class. But I wanted to show you a program. This is Desmos. Its web address is desmos.com. This is just a kind of more visual, more up-to-date, more 2020 graphing calculator. So you can see when you go to the website, you're going to have a button here right in the center that says graphing calculator. So if you click that, that's going to go open up a coordinate plane with a place for you to enter equations. It does a lot of stuff that we're not even going to get into, but this is something you can keep in mind. You can use this when you're trying to understand the concepts that we talk about. You can use it while you're working on your homework. You just won't be able to use it on tests. So just keep that in mind, that you do need to learn how to use the graphing calculator, because that, you don't want to be trying to figure that out when you're taking a test. But if you're having trouble visualizing, or you just want to play around and just see what happens when you do different things to an equation, this is a great program. Very easy input, very easy to manipulate. So let's start with our first equation that we graphed tonight. That was that line. And you'll notice over here on the left, it has a place for me to put an equation. And the great thing is I don't have to do anything to that. I'm just going to type it in. You can see the line keeps moving as I type. So I just typed in exactly how it was on the paper. I didn't have to solve for y. I just put in 3x plus 2y equals 18. Simple, easy. The other thing that's really cool is you can just drag this around. So if I was trying to find this point up here, it looks like it crosses the y-axis at 9. I could just drag this down and I could see that. In fact, I can even put my mouse there and it kind of pulls into those points that are the special points. And when I hover over that, I see that it's the point 0.9. Down here, the x-intercept is 6, 0, so it's just really cool. In any place along here, I can draw a point, and it tells me the x and y coordinates for that point. And we've talked about, I think this really helps visualize that every single point on this line makes the equation true. If I were to plug x equals 2.68 and y equals 4.98 into that equation, there might be some rounding error because those only have 2 decimal places, but basically, when I plug those in, that left side is going to equal 18, and it makes the equation true. Okay. You can also use the plus and minus over here to zoom in and out. And I believe on a touch screen, yeah, I have a touch screen, and I'm able with my fingers to zoom in and out by pinching as well. If I want to put a second equation, I'm just going to put the second equation right here on the same graph. There we go. Plus 4x minus 20. And there's our parabola. Now this time, in order to get down there to the bottom, I just drag it up. And I can get right down there, and I can see where the lowest point on that parabola is. And it looks like it's right at -2, -24. We are going to learn how to find those points, like those intercepts that we just talked about, and this lowest point on our graphing calculators, but you have to do a little bit more behind the scenes. It's not as visual where you're just clicking. And it knows if you're clicking around down here, you're probably looking for that lowest point, which is called the vertex. And when you're clicking up here close to the x-axis, it knows that you're trying to find that intercept, which is 2.8990. Again, it's desmos.com. You might want to jot that down and keep that in mind, but don't neglect learning how to use the graphing calculator as well. Okay, that's it for this video. Hopefully that was helpful and got you down the path of understanding graphing calculators a little bit better.